Hello, welcome to this lesson of our study of differential equations, and this is particularly in ordinary differential equations, ODEs. Okay, so if you have not subscribed to the channel yet, kindly subscribe to the channel to support it as well. Okay, like my video, comment, and also share it. Okay, and trust me, for all my videos I give trial questions, so I would always urge you to work on the trial question, and you comment in the comment section to tell me that you were able to do it or not. Okay, all right, so in this lesson what we'll do is we'll go through one way of solving a first order ODE. Okay, so this whole lesson is about first order ODE, and this method is called separable method. When you have an ODE that you can separate it, then you use a particular method to solve it. Okay, so we'll be going through all the series of methods in solving first order ODE, and this is the first one, that is the method of separable method. Okay, let me put it that way. All right, so let's start now. If you have an ODE, a first order ODE, we know that a first order ODE can be rewritten as dy dx. If you can make dy dx the subject and write it as this, okay, that dy dx is equal to something like this, where this f of xy can also be broken down or separated into two functions like g of x times some small h of y. Okay, if f of xy can be rewritten as that, then it means that dy dx is actually equal to the product of these two functions. Okay, and that what you do is, this is where the method of separation comes in, or the separable method come in. What happened here is that you try to group the y's and then dy's at the left side of the equation, and you group the x, or the functions that includes only x, and then the x at one part of the equation. So here realize that dy dx equals, from this equals g of x to h of y. Then if I multiply through by the x, then I have this one. Okay, I have dy equals g of x h of y, then dx. Okay, yes, too, I have some h of y here, but I want only x stops at the right side of the equation. So all I have to do is divide through by h of y, and then I'll get 1 over h of y here at the left side, and I'll be left with this at the right side. So you realize that the left side of the equation includes only variables in y. Okay, here is only y variables, and then the right side is only x variables. Then you can integrate through the equation based on their respective variables. Okay, so integrate the left side of the equation with respect to y, that is that variable there alone, and then in that case all functions here will be in terms of y. Then integrate the right side with respect to only x, where all functions will be in terms of x. Then after integrating 1 over h of y, we assume that the solution you get is capital H of y. Okay, so this capital H of y is just the solution you get for integrating the whole of this. Okay, and then when you integrate that part of the right side of the equation to, we assume that you get capital G of x. Now you realize that this is indefinite, or this is indefinite integral, so both sides of the equation will get constants. Okay, but at the end, if you subtract or add them, you still get another constant. Okay, it can happen that the constant at the left side will be bigger than the constant at the right side, or it can happen that they will be the same, that when you subtract you get 0. Okay, what I want to say is that when you integrate at the left side you get a constant, let's say a, and when you integrate at the right side you get a constant, let's say b. But if I make h of y the subject, it means I will send a to the right side of the equation, so I'll get the constant to be like, let's say b minus a. Okay, and this whole b minus a is what we've written as the c. So at the end, b minus a is still a constant. Okay, but if they are the same, then we get 0. If they are not the same, then we get another constant, let's say c. I hope you get this. So this will be the solution, provided your differential equation can be separated into these steps, as in functions of x and dx alone at one side, then functions of y and dy alone at one side. Now let's go and pick some series of examples, and work on them. Okay, so the first example is solve the ODE. This, okay, dy dx equals x plus 1 over 2 minus y. This is very simple, right? I hope you can see this, because if I multiply through by dx, I have dy equals x plus 1 over 2 minus y times dx. Okay, I want to make sure that I have only y and x steps, and then the dy and the dx steps at one place. Okay, now here there's still y in the right side of the equation. We don't want to see y here. We want to see, since we have the s here, we want to see only x in these functions. Okay, so what you can do is you take the denominator, which is 2 minus y, and multiply through the whole of the equation. So you have 2 minus y multiplying dy, then 2 minus 1, you multiply it to this side, the right side of the equation, it cancels the denominator. So you have x plus 1 dx. In effect, you are separating them into their respective variables. Okay, so realize that only y's are here and only x are here with respect to dy and then dx. Okay, so what you do is simply just integrate. Once you're able to separate them like this, then use this to solve it. We integrate with respect to their variables. Okay, the integral x plus 1 dx. Okay, when I integrate 2 minus y with respect to y, I get 2y minus half y squared. Okay, then there should be a constant. Okay, this indefinite integral, so there should be a constant, but let me put it there and then I'll explain. I will raise it later. Okay, let's say plus a constant a, and when I integrate x plus 1 at the right side, I get s squared over 2, or half s squared plus x. Okay, plus another constant, let's say b. All right, so if I put everything, or if I multiply through by 2, okay, I get 4y. I want to get a linear something. I don't want to see fractions in. Okay, then minus y squared plus 2a equals s squared plus 2x plus 2b. Okay, where a and b are constants of integration. Okay, so when I let's say I'm sending the right side of the equation to the left, so I have 4 minus y squared, or 4y minus y squared, sorry. I would do some simplification here, but I want you to understand what I'm doing. Okay, my plus 2a minus s squared minus 2x minus 2b equals 0. Okay, so therefore let me divide through by negative 1. I want to see the s squared and the y squared being positive. Okay, so if I divide through by negative 1, I have s squared plus y squared minus or plus 2x minus 4y, then plus 2b minus 2a equals 0. Now the whole of this we are saying is a constant because they are both constant. So when I multiply 2 by that, and 2 times b is still a constant, and when I subtract this, or when I subtract 2a from it, I'll still get a constant. So let's replace the whole of this 2b minus a that we had by a constant, let's say c, and this equals 0. So in some books, what they do is after the integration, they simplify everything, then your final answer, and you add a constant c. Okay, so always that will work. So this is the solution to the differential equation. Some books will require you to make y the subject, and looking at this, you realize that y is in each quadratic term, so you have to work a lot for making y the subject. So in order to make y the subject, you have to use the idea in quadratics. Okay, let's go to the second question, and that one involves more in tedious integration than this. Okay, but one thing I want to remind you of is that make sure that your integrations are really strong before you do differential equations. So if you've forgotten about integration, kindly remind yourself on those steps. You can check on my videos on integrations and stuff. Okay, all right, so with this, to solve this ODE, what you do is, like I said, just make sure that you separate them by just multiplying through by dx. Okay, then 1 plus x squared all times dx. Okay, now if I divide through by 1 plus y squared, or if I multiply through by 1 over 1 plus s squared, so I'll multiply here by 1 over 1 plus y squared, then dy should be equal to 1 over 1 plus y squared, multiplying that, and you realize that it will cancel this one. Okay, let me write it. You realize that this will take this away. Okay, so in effect you get 1 over 1 plus s squared here at the right side, then the x. Okay, know how to manipulate to get your separation. Okay, so I have 1 over 1 plus s squared dx. So you realize that the left side of the equation you have only variables in terms of y, and then at the right side you have variables in terms of only x. Okay, so you integrate both sides. 1 over 1 plus y squared dy equals integral 1 over 1 plus s squared dx. Okay, now I'm quoting the formula here, and then I'll go through with you. When you integrate 1 over 1 plus y squared dy, you get tan inverse of y. Okay, because when you integrate, that same happens to x, tan inverse of x, then all plus c. Now, like I said, you just add one c to the integration. Okay, so the final answer is tan inverse of y, or arctan y, equals arctan or tan inverse of x plus c. This is the solution. Okay, now the reason I'm just reminding of this, the solution to 1 plus y squared dy, then you apply the same thing to the integral of that. Okay, let me go through quickly with you. Here you recall that you use trigonometric substitution, that when you have integral of 1 over a fraction, and then we have some a squared plus x squared. Okay, when you have a squared plus s squared, then you recall that 1 plus tan theta, tan squared theta equals sec squared theta. Okay, so what you should do is you make sure that this appears in this integration. So you let the y that you have here be equal to tan theta, and then you know that the theta dy, or dy the theta, okay, will be equal to, when you differentiate tan theta with respect to theta, I get sec squared theta. Okay, and then what happens next is that you make dy the subject, meaning dy will be equal to sec squared theta d theta. Okay, and you just come and put them here. You have 1 over 1 plus y squared, y is tan theta, so you become 1 over 1 plus tan squared theta, and we said that is also sec squared theta, so I'll have sec squared theta here. Then dy is what? Sec squared theta d theta, so we'll have sec squared theta d theta. Okay, then sec squared theta will cancel sec squared, so you have integral of 1 d theta. Integral of 1 d theta will give you what? Theta. In terms of theta, you get theta plus a constant. But we said tan theta is equal to y, meaning that my theta will be equal to, that the solution will be just tan inverse of y. That is why when you integrate this, you have tan inverse of y, and when you do same for x, you get this. Okay, I hope you understood this. If you don't really remember this, like I said, I have videos on integration. I have a particular lesson on integrating trigonometric functions, logarithmic functions, and exponential functions in one video. Okay, so you can check that one out. Now solve for y in this. Okay, so like I said, always remember your integrations. Okay, so here we'll go through a very tedious integration, but I'll go through them with you. Okay, don't worry. So to solve this, like I said, make sure you separate them. Okay, so I have 5 dy dx. Okay, dx equals, the question is solve for y. Okay, so make sure that after everything you make y the subject. This is some of the questions will ask you, yes, make y the subject. In the previous one, let's say if you want to make y the subject, I have to find the tan of both sides. If I take tan of tan inverse, then I'll get y, and then that will be this the right or the left side of the equation, and then this side I'll have to find the tangent of all of these, and that will be my solution. Okay, now with this, you're supposed to solve for y, so after everything you have to make y the subject. Now this is equal to 2y squared minus 7y plus 3. Okay, so to do this, 5 dy, always try to make sure you multiply through by that, by dx. Okay, so plus 3, then dx here. Now realize that there is no x in this, so I can divide through by the whole of that. Okay, so I have 5 over 2y squared, okay, minus 7y plus 3 dy, and this is equal to 1 dx, because when divide through by that, I'll get 1 at the right side. Okay, so what happened is that I just integrate both sides, since we have only y in these aspects with respect to dy, and we have a constant here with respect to x, and that is no problem to us. Okay, so everything tends to be integral of 5 over what is it y squared or 2y? So 2y squared minus 7y plus 3, right? Then dy should be equal to integral 1 dx. We know integral 1 dx will give me just x. Okay, so that one we don't stress ourselves much on it. So I have integral 5 over, when you factorize the denominator of this using quadratic factorization, you have 2y minus 1, then y minus 3 dy should be equal to x plus c. Okay, so after everything, just one constant, so just keep this c. Okay, now this is what I have. Now my task here is to go and look for the integral of this, okay, over 2y minus 1 then y minus 3 dy. Now this should be equal to, using partial fractions, I have I would write, or let me go through the partial fractions with you. I don't want to skip steps. Okay, so let's split this 5 over 2y minus 1. Is it 2y minus 1? Yes. Then let me clean this and write it well. I want to go through all the steps with you. 5 over 2y minus 1, 2y minus 1, okay, then y minus 3, then this is equal to, let me write this well, this should be equal to, in partial fractions, a over 2y minus 1 plus b over y minus 3. I'll be skipping some steps. I hope you remember partial fractions. Okay, then 2y minus 1 y minus 3. If I solve the right side of the fraction, I have a into y minus 3 plus b into 2y minus 1 all over 2y minus 1 y minus 3. Now I realize that for the both side of the equation, the denominators are the same. Simply means that, and then we have an equal to sign here, which simply means that the numerator should also be equal to, or the numerator should be the same. So I have y minus 3 plus b into 2y minus 1. Now to find b and a, it depends on how you can do it. Okay, so having this, some people will just look through this and they know their solution. Some through, I'm sorry, I've interchanged them. Okay, I've actually interchanged them. This, I have a into y minus 3. This is 2y minus 1. Okay, so what some people can do is that when y equals, so when y is equal to, when y equals 3, what do I have? It means when I put 3 here, I'll have 0 for that place. So I have 5 is equal to a times 0, which will be 0, then plus b times 2 times 3 is what? 6 minus 1 will give me 5. So I have 5b, and this will imply that b equals what? 1. And when y is equal to half, okay, I'll have a into half minus 3. Half minus 3 is simply minus 5 over 2. Okay, and so I have 5 is equal to minus 5 over 2a, and with that, this b part will give us 0. You have b into 0 because we have 2 times half, which will give me 1, minus 1 will give me 0. So this implies that if I make a the subject, I have a equals minus 2. Okay, minus 2. Then quickly, this means that the whole fraction, this, okay, has now turned to become a is 2 over minus 2 over 2y minus 1, then plus b is 1 over y minus 3. So the integral, we had integral 5 over 2y minus 1 y minus 3 dy equals some x plus c. Now this has turned to become integral minus 2 over 2y minus 1 dy, or let me plus 1 over y minus 3 dy, okay, is equal to x plus c. Now you have to integrate them, these ones term wise, okay. So if I pick the integral, the first part, I have integral minus 2 over 2y minus 1 dy, okay. That is the first part of the integration. I mean, this fraction, since we have this plus this, I can take them term wise and integrate them, okay. So when you do this, you have minus of integral of this over 2y minus 1 dy. Now there's this identity that when you differentiate the down one here and you have the top here, then the whole solution of this integral is equal to ln of the down one. But if you don't want to get confused, you can use substitution, use u equals 2y minus 1 and then start simplifying. I hope you understand how to use substitution in integration. And this whole thing will give you ln of, so there is a minus already here, okay. So I have negative ln of 2y minus 1, okay. From what I just said, I said that when you differentiate the denominator, when you have a fraction and you are integrating, and when you differentiate the denominator and you get the numerator, then the answer is just the ln of the denominator, okay. So the solution to this is that, and then the other one is this y minus 3 dy. This one too, when you differentiate the denominator, you get 1, which is the numerator, okay. So the solution to this is also ln of y minus 3. So this simply means that these are the solutions, okay. So I'm coming to erase everything. Then what I write here is, we know that, okay, so we are write the answers for these. This will imply that we have minus ln of 2y minus 1 and plus ln of y plus 3 is equal to x plus c, okay. I hope you get this. So what will happen here is that this is very, very simple. We'll go through it, very simple. And this simply ln of y plus 3, I'm just interchanging these, minus ln of 2y minus 1 equals x plus c. Now the question asks that to solve for y, so we could have actually leave everything in this, okay. We have logarithm here, so y plus 3 over 2y minus 1 equals x plus c. We could have actually left everything like this, but the question is asking us to solve for y, so we have to make y the subject, okay. Now logarithm ln means that logarithm to the base e. So if I write this, I change this ln to the base e, I have log of this to the base e of everything here. So if I want to do away with the log, then all I have to do is let the e come and raise this power, okay. So I have y plus 3 over 2y minus 1 equals e to the x plus c, okay. So I have y plus 3, okay, y plus 3 equals all over 2y minus 1 equals e to the x times e to the c, and then e to the c is still a constant, okay. C is a constant, so e to the c will give me a number which is a constant as well. So I have times some a. So quickly I erase this and write it a e to the x, okay. I hope you get this. So a e to the x, and then when I multiply through by the denominator, I have y plus 3. Here is just doing algebra here, okay, just manipulation and simplification. So you have y plus 3 equals a e to the x, or 2a to the xy minus a e to the x, okay. I hope you get this. So this is very, very simple. This is very simple. I take the y here to the other side of the equation. I have y minus 2a e to the xy equals, is this y plus 3 or y minus 3? I think it's supposed to be y minus 3. Yes. So all this while we've been writing a different answer. Here is minus, and I think here 2 is minus, here 2 is minus as well, here is minus. Okay, so they're supposed to be negative, negative, negative. Okay, let's go back to this and realize that here 2 is minus, here is minus, here is minus, and here is also minus. Okay, minus, minus, minus. Okay, so when you pick minus to the other side, I have 3 minus a e to the x, right? So factor y out in this one at this part, and I have y out. Let me write it at the top. 1 minus 2a e to the x, and this should give me this part 3 minus a e to the x. Okay, now y will be equal to 3 minus a e to the x over 1 minus 2a e to the x. And if you factor negative out from both numerator and denominator, they will cancel out. You get something like this: a e to the x minus 3 over 2a e to the x minus 1. This is also true. Okay, I hope you get this. So these are some of the simplifications you can be doing. Now let's go to the next question. The next question is saying solve for y in the ODE. So this whole thing is also requiring us to make y the subject after everything. Okay, so what will happen here is, let's try to make sure that this part of the equation, okay, the dy dx is standing alone. This time around, we have something plus this, and we don't actually have, what do you call it? Wow, my background is changing. Okay, so we don't actually have what we call the dy dx equals something. This time around, we have to manipulate it. So we have e to the x plus 2y dy dx equals negative minus 1 minus x all squared. Okay, so let's split the e to the x. We have e to the x dot e to the 2y dy dx, okay, is equal to minus 1 minus x all squared. Now if I divide through by e to the x, okay, I'll get e to the 2y dy dx is equal to minus 1 minus s all squared. Okay, then e to the negative x, because when you divide through by that, it will come here. When I divide through by e to the x, I have this over e to the x, and this will take this out, and when it comes to the right side, it's the same as e to the negative x in the linear form. Okay, I hope you understand this. So here we make, there is still a dx in this, so you multiply through by, at this side you multiply through by what? Dx. So we have e to the 2y dy equals negative 1 minus x all squared e to the minus x dx. So here we've been able to separate them. What you do again is just integrate. Okay, so integrate e to the 2y dy then equals integral of minus 1 minus s all squared e to the negative x dx. And when you integrate the left side of the equation, you have 1 over 2 e to the 2y equals minus integral of 1 minus x all squared e to the minus x dx. Now here, our task here becomes very tedious, because the right side of the equation is not just simple like that. You have to use what we call the integration by parts, but going through it systematically, trust me, will not finish. And so I will use the table form. Okay, we have a table form of doing the integration by parts. So with the table form, you pick the two functions. I believe you have only two functions here, so all that you do is you pick the two functions. Okay, then you realize that when I start differentiating 1 minus x all squared, it will get to a point that I will get 0. Okay, So you pick that one and start differentiating, and then the one that when you integrate or when you differentiate you won't get 0, you keep it and integrate that. So we differentiate the first column, that is this part. Okay, this part. When I differentiate this for the first time, I'll have to differentiate the bracket with respect to x. I hope you get this. And that will give me minus, okay, minus x, minus 1. Now multiply it by the power here, and that will give me minus 2 into 1 minus x, then 2 minus 1, which will give me just 1. Now integrate e to the negative x is minus e to the negative x, because you have to differentiate the power, and you get negative 1, then you divide it by. So integral of this, I'm just doing this, is just 1 over the differential of the power with respect to x, and that is negative 1. Then you write this back, okay? So that is this. So you have negative e to the x, and you continue differentiating this one again, okay? I mean, you have to differentiate this again, and when you differentiate that, you differentiate minus 2 into this. Minus 2 here is a constant, so the only part you differentiate is this, okay? The minus x, 1 minus x. When you differentiate 1 minus x with respect to x, you get negative 1. Multiplying it to this, you get 2, okay? Then 1 minus x, okay, I'm using chain rule here. Here power is 1 here, so 0, and that will give me what? 1 minus x all to the power 0 is what? 1. So I'll get only 2. I just wanted to show you why I have 2. Then integrate e minus e to the x, I'll get positive e to the x. The same process. When you differentiate this, you get 0. When you differentiate, you have minus e to the negative x. Then the thing is that we are trying to find a function that when you differentiate, you get 0 at some point, because that is why we just use a table. But in some partial differential equations, partial integrations, okay, when we are doing partial integration or integration by parts, let me put it that way. In some integration by parts, you will never ever get to 0, so you have to use some other system or other methods, okay? But here realize that this can give us 0, okay? So that is it. So here the final answer is that you come and write these. You start taking them diagonals, okay? You take this and multiply it to this one, okay? You take this one and multiply it to this one, and you take this and multiply it to this, and you take this and multiply it to this. The 0 wouldn't count. So when you're multiplying, after multiplying the first one, you multiply them by a positive. Okay, let me use a different color. After multiplying the first one, multiply the product by a positive. Then with the second one, you multiply by a negative. Then this you multiply by a positive. So it's plus minus plus, okay? So it means that the whole of this integration, okay, let me write it here. The whole of this integration, 1 minus x all squared e to the minus x dx, would then be equal to, I multiply the first two terms, and you say multiply by positive, okay? So when you multiply this and 1 minus s all to the power 2, you still have minus e to the negative x, 1 minus x all squared. Then you add it to the product of these two. But after that, we said you multiply by a negative, okay? When you multiply e to the negative x to the minus of this, you get negative. When you multiply this minus to it, you get positive. So this one plus e to the negative x, then you have 2, or let me put some 2 here, 2 e to the negative x, and 1 minus x. I hope you get this. I hope this is cool, right? So then you add it to the product of this and this. Now 2 times negative e to the negative x, you have minus 2. But I multiply by a positive, and you have what? Minus. So I have minus 2 e to the negative x. So this is the solution to this the integral side here. So putting them back in the equation, I have half e to the 2y is equal to, now I realize that there was a negative in front of this, but only this part gave us the whole of this, okay? So what you can do is you write a minus in front, okay? minus in front of everything. Okay, so I have minus. Then you start simplifying whatever you had. Okay, now I have this. When I expand this side, 1 minus s all squared, I'll have, there was a negative already, so negative e to the negative x. Now when I expand that, I have 1 minus 2x plus s squared. Okay, then when I expand this side, okay, when I multiply the 2 through this, or let's say I expand 2e to the negative s, I'm expanding it with that. That is, I'm expanding this side, 2e to the negative s, multiplying that, I have, is it minus? No, it's plus. Actually, it's plus. So I have plus 2e to the negative x minus, let's see, yes, minus 2e to the negative x, 2x actually, e to the negative x. Then you expand the last one. The last one is actually minus 2e to the negative, so I have minus 2e to the negative x. All of these multiply by the negative, then everything plus c. So I have half e to the 2y equals minus into this, multiplying this one. This simplification, you can do it yourself. Okay, so when you simplify the whole brackets, you have, let me go through it. Okay, I started with you, so I have to end with you, right? Plus 2x e to the negative x, then minus e to the negative x s squared, then plus 2e to the negative x, and minus 2x e to the negative x minus 2e to the negative x. All of these in one bracket plus c. Now realize that this will cancel this, and so this will also cancel that. So I'll be left with half e to the 2y being equal to minus into minus e to the negative x minus e to the negative x s squared. Okay, I can factor minus e to the negative x out, and we'll have something like half e to the 2y equals minus into minus e to the negative x 1 plus s squared. Okay, then this negative will go, and I have half e to the 2y equals e to the minus x 1 plus s squared, all plus c. There's a plus c here. Okay, I hope you get this. And let me multiply through by 2. Okay, and I'll have, because I want to make y the subject, then I have 2e to the negative x into 1 plus s squared, then plus 2 times the constant c. Let me call that k. K is 2c, and that is still a constant. Okay, so if I pick the length of both sides of the equation, okay, if I pick the length of e to the 2y, okay, it's 2y rather, 2y, this should be equal length of 2e to the negative x into 1 plus s squared. Okay, 1 plus s squared plus k. Right, then this will give me 2y equals ln of 2e to the negative x 1 plus s squared plus k. Now I realize that the ln has gone, is gone, or has vanished in the left side. Okay, because when 2i comes down, you have ln of e, and ln of e is 1 because ln is the logarithm to the base e, and then that will give me 1. Okay, so I have y, finally y is simply equal to half ln of 2e to the negative x into 1 plus s squared plus k. Okay, and some people will just take this half into it and still say that since this is logarithm, I have this, then the square root of 2e to the negative x 1 plus s squared plus k. I hope you get this. So this is very simple, right? Now let's take the last question, and then I'll give you some trials to go and work on. Okay. So the last question is saying that we should find a solution y for the differential equation. This with some conditions. So with y equals 0 at x equals 2. So when x equals 2, I have y equals 0. So quickly, let's go through this together. You have x dy dx equals the square root of y squared plus 1. Okay. Now, when I do some reshuffling, let me divide through by x, and I have dy dx. Always let's try to make dy dx the subject first. I have this plus 1 all over x. Okay. This implies that if I multiply through by dx, I have dy equals square root of y squared plus 1 over x, then dx. Now, there's still some y in the right side, so let me divide through by square root of y squared plus 1. And I have 1 over square root of y squared plus 1 at the left, dy equals 1 over x dx. Okay, I just divided through, and then that will be this. So here we've been able to separate our differential equation into this. Okay, so what you are coming to do is just find the integral of both sides. Okay, so this has turned to become the integral of 1 over square root of y squared plus 1 dy equals 1 over integral of 1 over x dx. I know that integral of 1 over x dx is very simple. It's equal to ln of x, okay, plus c. So that one you add a c to it, but with the left side you don't add a c. Okay, so we are coming to work on this integral of this y squared plus 1 dy. Okay, now to work on this, let me quickly go through it with you. I could have actually quoted the formula. You can use hyperbolic functions, and in hyperbolic function you have cos squared theta minus sin squared theta equals 1, which means that cos squared theta is equal to 1 plus sin squared theta. And so if you let sin theta be equal to y, that would work for this. But with that, making y the subject becomes something else. You have to go and quote another trig hyperbolic identity, and that I don't want us to waste or maybe spend much time there. So I'll use a trig identity straight away. Okay, so straight away what you do is, like I said, recall that when you have a squared plus s squared, or let's say here we are dealing with y, so a squared plus y squared, recall that we have tan squared theta plus 1 is equal to sec squared theta. So whenever you have the plus, but also remember this cos squared theta plus sin squared theta is equal to 1. So when you have, let's say, 1 minus something, okay, 1 minus s squared, then realize that 1 minus sin squared, any way of them, equals cos squared theta, and then you use this substitution rather. Okay, so let's actually look at this and then use what we are supposed to use. Okay, so here you want this to look like this. Okay, you want the one in the square root to look like that. So you let our y be equal to, like we did for the second question, our y be equal to tan theta. This means that my dy d theta will be equal to sec squared theta. This simply means dy is equal to sec squared theta d theta. Okay, now I come and put it here, but let me y squared would be equal to tan squared theta. That is one thing you should also know, meaning that 1 or y squared plus 1 would then be equal to tan squared theta plus 1, and that will be equal to what we have written it here, sec squared theta from this side. Okay, so it means the square root side will go to the sec squared theta for this substitution. So I have the square root of sec squared theta means that the square root of sec theta all squared, and that will give me sec theta. So square root, I'll just substitute everything. Y squared plus 1 will be square root of sec squared theta, and that will be equal to sec theta. Okay, so putting everything that we've done so far, we have integral 1 over the square root of y squared plus 1. We said is what? Sec theta. So we put it back, sec theta. Then what is my dy? My dy is equal to this part, sec squared theta d theta. So I have sec squared theta d theta, and sec squared theta means sec theta all squared. So this will take one of the sec squared theta, and then we'll get only sec theta. Okay, so this whole thing, let me stop that and write this whole thing being equal to integral of sec theta d theta. Now this integration is also not easy, because we do some creating and destroying here. Okay, let me help you with that. You create and destroy this sec theta, then sec theta, I think I have a video on this, plus tan theta over sec theta plus tan theta. At the end, this is 1, and it doesn't change anything, all the theta. Okay, it does not change anything. It gives you, when you cancel them, it gives you back the question. But I don't want to cancel. One will multiply through sec theta through the numerator, and you have integral of sec squared theta plus sec theta tan theta over sec theta plus tan theta d theta. Okay, so with this, I just wanted to go through the integration with you. I'm not supposed to do this, but like I said, we mostly forget about certain things, so let's go through it together. So you let some u be equal to sec theta plus tan theta, meaning that du d theta will simply be equal to, when I differentiate sec theta, I have a video on that one too, is equal to sec theta, and differentiate sec theta, I get sec theta tan theta, plus when you differentiate tan theta, I have sec squared theta, and that's meaning making the theta the subject. The theta will be equal to du over sec theta or sec squared theta plus sec theta tan theta. This is true, right? So we come and substitute these stuffs into this. Okay, we're saying that the whole of the denominator here is my u. That's why we just said that the u should be equal to sec theta plus tan theta. So I have integral, then the numerator was sec squared theta plus sec theta tan theta, right? Over denominator, and denominator is u, that is sec theta plus theta, times the theta, right? The theta is du over, let me put a bracket here, du over sec squared theta plus sec theta tan theta, right? And this whole thing will take this whole thing away, so we'll be left with integral of 1 over u du. Okay, so if, let's say, your teacher asks you to prove everything, then you do what I'm doing, and this will be equal to ln of u. Okay, and u is what? U is sec theta plus tan theta. But in terms of y, we are doing everything in terms of y. We know that in terms of y, tan theta is equal to y, or y is equal to tan theta. What would be the sec theta? So if I put theta in right angle triangle, tan theta means opposite over the adjacent, which is 1, because y is the same as y over 1. Okay, so that will be the adjacent, and then the hypotenuse will be equal to y squared plus 1, or plus 1 squared. But sec theta is equal to 1 over cos theta, right? So meaning cos theta from this diagram is equal to adjacent the 1 over the hypotenuse, which is y squared plus 1, meaning that sec theta will be equal to 1 over this, and this will be equal to square root of y squared plus 1. Okay, so sec theta is equal to square root of y squared plus 1, and tan theta is y. Okay, so I'll come and put everything here, that I'll have ln of sec theta plus tan theta, and tan theta is y, sec theta is square root of y squared plus 1. That is the integral for the y aspect. This is the integral we had for this aspect. Okay, so this aspect gave us what we just had. Okay, so it gave us what? Let me write it here for you. It gave us ln of y plus the square root of y squared plus 1, and then the other side gave us ln x plus some constant c, but this constant c can be written as ln of a. It's still ln of a is a constant, so ln of a is still a constant. You want to do away with these ln. Okay, so let's put that there, and then ln y plus square root of y squared plus 1 would then be equal to ln of x plus ln a. Okay, that's the right side of the equation using logarithm will then give us something like this, equals ln of ax. Okay, a times x. Now, if taking anti-logarithm or anti-logarithm of both sides, I have y equals, y plus square root of y squared plus 1 equals ax. This is a general solution, but we want to make y the subject. But you say y is equal to what? 0 at, is this 0 here at x equals what? 2. So putting y equals 0 here, I have 0 plus square root of 0 plus 1 equals putting x equals 2. So meaning I have 1 equals 2a. This implies that a equals what? Half. Meaning y plus square root of y squared plus 1 should be equal to half x. This is a solution. But I want to make y the subject because they said we should find a solution y. Okay, so we have y plus square root of y squared plus 1 equals what was it? Half x. 1 over 2x. Okay, now if I make square root of this the subject here, then I'll have half x minus y. Squaring both sides, I have y squared plus 1 equals the square of this side minus y, then square it. So I have y squared plus 1 equals s squared over 4 minus 2xy. So 2 times this times that, and I'll have xy plus y squared. So that if I put y squared back to the left side, this will take this away. Okay, then we'll have something like xy is equal to s squared over 4 minus 1. Okay, this is what you have from this equation. The meaning y is equal to, dividing through by x, I have x over 4 minus 1 over x. This is pretty cool, right? So this is a solution to the question that was being asked. So they are very, very simple. The trial I have for you is that solve for these ones. The first question is e to the x dy dx plus y squared equals xy squared. Then at y equals e, s will be equal to 1. Solve for y, and then the answer is equal to y is 1 over x e to the x. So solve for these. Okay, make y the subject after everything. Now the next question is what is it? Y equals, okay, y is equal to 1 minus dy dx into x plus 1 over x minus 1, x plus 2, and then there's a bracket here, and then at y equals 2 we have s is equal to 0. Now solve for this, and the answer, making y the subject, the answer is that y is equal to 1 plus x plus 1 squared e to the negative s squared over 2. Okay, and then the last trial, I want you to go through all these trials. Okay, dy dx, this one the question has made it simple, equals 1 minus square root of y. Then at y equals 0, x is equal to 0. Now the answer is x is equal to 2 ln of 1 over 1 minus square root of y minus 2 square root of y. So realize that here, I'm not sure you're able to make y the subject. So that is it. And I'm urging you to subscribe to my channel if you have not subscribed. Thank you, and see you next time. All right, bye.